So let's try that. Let's determine example 2, determine the term that's indicated for each of the following sequences. Oh yeah, so the term indicated. Okay, so what? Oh, this one says the 8th term. Okay, so we want to find the 8th term. Okay, so again, like everything else, it's good to kind of write down what we know. So T1, our first term, is 2. Now our ratio R, take a number divided by the previous. 10 divided by 2. How you write that, by the way? T2 divided by T1. That's what we're doing here. Term 2 divided by term 1, which is 10 over 2. Now, it doesn't have to be those ones. It could be 50, term 3 divided by term 2. Sometimes it's easier. But generally, we just do the first two. 10 over 2, which is 5. The number of terms, n, it tells us, is 8. Okay, so our formula, Tn is equal to T1 times R to the power of n minus 1. Okay, so we're going to go T8 is the first term, which I've forgotten already. I think it's 2, is equal to, or sorry, not equal, T is 2 times 5, so 2 times 5, to the power of 8 minus 1. Now, a bunch of people want to go 10. 2 times 5 is 10. And you're right, 2 times 5 is 10. However, we have to do bedmass. Bedmass says exponents, so I have to do the exponents first. If it says brackets, I got to do the inside of the brackets first. So 2 times 5 to the 7. Now, here I have to use bedmass again and do the exponents. And this is why we're using a calculator, because 5 to the 7 is 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5 times 5 times 5. And it just becomes really tedious. Especially 8 is not bad, but later on we're going to go 35. Who wants to do 5 times 5 times 5 35 times? So you can bring up a calculator here. So I've got 5 to the 7. So 5 to the power of 7. 78,125. 78,125. And then I need to double it. So you can bring out your calculator again. 78,125. And times that by 2. 156,250. 156,250. So that is what term 8 is. So I'll zoom out here. And we can do the next one, which is the 10th term. So T1, first term is 12. Now our ratio is 6, our second term divided by our first, 6 over 12, which reduces to 1/2. Or, because we're using a calculator, sometimes 0.5. And the number of terms, well, it says it wants to do 10. So Tn is equal to T1 times R to the n minus 1. And so we're doing T10 here. And 12. Those are our first term. So T10. And yeah, 12. And then 1/2. To the, you don't need brackets in it, but sometimes you can. 1/2, you can just put a dot sometimes. 10 minus 1. So that's 12 times 1/2 to the 9. Now, maybe I will put brackets just around this, because you're going 1/2 to the power of 9, and then we're going to times that by 12. And this is crazy. 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. I mean, technically this 9 can go into both of those. So you're going to have 1 to the power of 9, which is 1. But then what? I don't know what 2 to the 9 is. That's a lot of 2s. I think it's like 64 or 128 or something. So, and then you got to times that by 12. So what we're going to do is just use a calculator. So brackets. 1 over 2, or 1 divided by 2, to the power of 9 is that. And then we're going to, I guess, times that by 12. So I'll write those down, but that is my final answer. So there we go. Our 12th or our 10th term here, T10, is this really small number. Now sometimes if you have a scientific calculator, it can put that back into a calculator for you, or sorry, to a fraction for you, and here it's 3 over 128. So we can write that here. $128, and then put a box around it. Okay. So let's keep going here because we're going to go more and more terms here. 20th term. Okay. So T1 is equal to 3. And what's our R? R is negative 12 divided by 3, which is negative 4. Just double check. Negative 12 times negative 4 is a positive 48. So that's good. And our N here is 20. For timesing by 4, 20 times, this number is going to be quite large. So we want to find, so first the formula, T1 times R to the N minus 1. So T20 is equal to 3 is our first term, and then our R is negative 4 to the power of 19, so 20 minus 1. So remember, don't multiply the 3 and the 4. Leave them separate because you have to do BEDMAS. So negative 4 to the 19. Now I don't know what all of that is. And notice I have this in brackets, and this is really important because 19 is affecting the 4 to the 19, but then there also happens to be 19 negatives. Now it's an odd number of negatives, meaning our answer is going to be negative. So I don't know what it is here. I know we have 3, and whatever it is going to be negative. So 4 to the power of 19, which is a huge number, where we have 2.7 blah, 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 times 10 to the 11. Okay, so I wrote down the number here, 2 point. Now, it didn't show up negative because I didn't put the negative in, because I already knew the answer was negative. There's 19 negatives. But what's good to keep in mind is that e to the 11, sometimes it shows that. That means it's times 10 to the 11. That means we're moving 11 decimal places over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's how big this number is. You put that decimal place all the way over here. And so there's 100,000 million to 274 billion. And then you got times that by 3. Okay, so go back to here. Take that number, times it by 3. So 8.24, but then we got to move it over 11 times. So let's do that now. 8 and it's negative. 8, 2, 4, 6, 3, 3, 7. If I'm reading this right, I'll double check after. 6, 3, 3, 7, 208. And I can move this over 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So add in this spot, we'll add a 0, and in this spot, we'll add a 0. So that is how big this is. I'm going to erase this. I'm going to erase that decimal place because that decimal place has now gone to the end. That is, and this is why we don't do this by hand. What you want to do, 824 billion, multiply 4 19 times? No. So keep that in mind. That these numbers can get really huge. Don't be afraid of the e to the whatever. That just means you've got to move the decimal place over, in this case 11 times. Okay, this is a little more reasonable. The 7th term. Okay, so T1 is 3. Our R, okay, our R looks strange. So 3 over 2 is the second term divided by the first term, which is just a 3. So I don't like writing vertically. Let's go 3 over 2 divided by 3. Well, that's 3 over 2 times flipping this fraction. Now keep in mind this is a fraction of 3 over 1, so we can flip that to a 1 over 3 and turn it to a multiply. Those 3's can cancel out, and you just have a half. So my r is equal to a half, and our n here is 7, because we're doing the 7th term. So let's try this here. Tn equals T1 r to the n minus 1. Okay, so let's find T7. And my first term is 3, and I have a half. And yeah. So I'm finding that term 7. My first term is 3, but then I have a half to the power of 7 minus 1, which would be 6. So 3 times a half to the 6. Now this 6 could come in. 1 to the power of 6 is 1, and then 2 to the power of 6. 2 to the power of 6. 2 times 2, 4, 8, 16, 32, 64. So this actually is 3 times 1 over 64. And then you can multiply, this is over 1, so you put the numerators together. 3 times 1 is 3. Denominators you get together, 1 times 64 is 64. So that is term 7. So there's no need for a calculator for that one. You could try to do that with a calculator, but it's not necessary at all because it's 2 to the 6. Just like it probably wasn't necessary for this one to the 9. Unless I did it wrong and it's not 64, maybe it's 30. Oh no, yeah, I think that's right. But yeah, I will just double check now. I'm just curious. 2 to the power of 6 is 64. So yeah. So that's that one. That was much more manageable. I didn't have to move any decimals over. So there we have it. I will stop it here, and we'll do the next video. We'll pick up on something that's a little bit odd. It's a little bit of guess and check.